Good afternoon, young people. Here's the first lecture on matter and energy called Describing Matter. So M, little m, is for mass. Mass is the amount of measurement of how much stuff is there. But it's really describing the number of atoms of stuff you have. Therefore, anything made of atoms has a mass. The measuring of mass is pretty simple. Balances are used to measure mass. You can use an electronic balance, looks like that. We can use a triple beam balance, it looks like that. We can also use balance scales. This would require us to have something on this side that is of a known mass and something of this side that is not, and to balance those out. The easiest one for us to use is the electronic. The metric unit of mass is in grams, and as you learned last year in physics, we use a lot of kilograms. So we do a lot of stuff in kilograms. So just be aware, kilograms is something that we do use sometimes. Okay, I'm trying to get my ink here. Okay, so kilograms is something that we do use sometimes in this class, but in chemistry we typically stick with grams. Kilogram is really used for physics mostly. V, big V, is for volume. Volume is the amount of space something takes up. So whether it's a speck of dust or Jupiter, all matter takes up space. So measuring of volume, we're going to use liquids measuring in a graduated cylinder. We could also use water displacement method if we have a liquid that is different. And we measure in liters or milliliters. So small graduated cylinders measure in milliliters typically. Larger things might measure in liters, but we can convert things very simply. Solids, we can actually measure dimensions. If it's a regular solid, we can measure the dimensions of the object. And if we have a formula, we can calculate the volume. But what if it's an irregular object? Irregular objects are going to take the process of water displacement. That would require us to use a graduated cylinder to put a known volume of water, and we're going to find the new volume, and we're going to subtract the known volume from the new volume, and this is the volume of the object. Okay, pretty simple, not too hard. But it requires to have a graduated cylinder that the object can fit into, that we can very precisely measure the volume of. Gases, well, gases like oxygen, they would be in tanks, but we know that gases expand to fill the container that it's in. So the volume of the container is the known volume of the gas. So if it's a 3-liter container and it's got a gas in it, it has a volume of 3 liters. Okay, but we can describe, so how can we describe stuff? We describe objects using different things like size and shape and color and texture, and these are all considered the object's properties. Those are the words that we talk about. We call these things properties. It doesn't matter what your object is, everyone can use similar descriptions. What were some of the properties we listed about today's demonstration? Well, most of you did do the alcohol fire. So you know that alcohol was clear. It was a liquid. The flame was orange and blue. We know that it was flammable. It was able to burn. Okay? We know that some of us put it on our hand, and when we blew on it, it was cool when blown on. Okay? So we know some of those things. All of these things are considered properties, things that describe what that material was that we were talking about. So properties, however, are constantly changing. For example, ice in your soda melts, glass breaks, paper is ripped. When ice in your soda melts, where does it go? Well, it just turns into water and it mixes in. Okay? What does it become? It just becomes part of the original solution. So that is why the original solution is now tasting what we call watery. We would call that watery, okay? So properties of matter. Remember, all objects take up space and have mass, and we use our senses of taste, smell, and touch and all of the other ones to tell the difference between things. So if we wanted to tell the difference between spinach and oranges, what would we do? Well, the first thing I think that we would think about would be the color. This one is green. This one is definitely orange. Spinach tastes different than that. So spinach tastes different than the oranges. Oranges have sometimes an acidic taste or a sweet taste. Spinach doesn't. Spinach doesn't have much of a taste at all if you really think about it, unless it's cooked, and then sometimes it's a little gross. So we have ways to describe the difference between these two things. Physical properties. Physical properties are properties that tell us what things look like. So oranges are orange. They have a round shape. They smell like oranges. Okay, they have a certain mass. They might take up a certain volume. They might have a density. Those are physical properties, what things look like. So when we're talking about what things look like or act like, we're talking about properties of matter. So these objects have different properties of matter. We have different properties for all of these objects. Yes, I'm being repetitive. So physical properties, she says, could I hold it in my hand? Yes, he's thinking of this object. Does it have an odor? Yes. Is it safe to eat? Yes. Is it orange, yellow, or red? And he says, no, no, yes. Is it an apple? So she begins to ask about different characteristics, different properties of the substance until she concludes what the substance is. Chemical properties are a little different than physical properties. They're not describing what something looks like. They're describing how it changes. So this is a property that describes how it changes. So iron rusts. Rusting is a physical property of iron. Or not, I'm sorry, not a physical property. Rusting is a chemical property of iron. The fact that iron forms rust is a chemical property. So these are properties that can only be observed by changes that we identify and see. A piece of paper burns and turns into a black substance. After the flame goes out, you can't burn the new substance. The new substance can't be burnt anymore. Chemical properties have been changed. So if we look at the fire, these blackened pieces will no longer burn very well. If you scrape off the black and get down to the wood again, it will burn. But if it's all black and charcoaly, you have to do something else to get that to burn. If we look at an egg, this is an egg cracked. This is an egg cooked. You can't get those to go back. You can't get this white to turn back into what was a raw white. It won't happen. So once a chemical property has been observed, that will no longer be changed back. We have to see a change happen in order to describe the chemical property. So milk needs to be in a refrigerator, else it will go bad. So spoiled milk doesn't taste very good. Here's an example of spoiled milk. What does it look like? You see these thick chunks on the top and you see this yellowy liquid on the bottom, and that is not milk. Milk does not look like that normally. That is not the physical description that you have with milk. Here, milk, on the other hand, here is some milk in a bottle, and we can see what this is, see what that looks like. But you cannot take spoiled milk and turn it back into unspoiled milk. It cannot happen. And so physical properties we might be able to change, or we might be able to reform. Chemical properties, we would not be able to reform those things and go back the other way. So more chemical properties. A common chemical property is reactivity. So we can react to oxygen, we can react to air, we can react to water. Notice that chemical properties aren't easy to observe, unlike the physical properties. They're hard to observe. So physical properties, again, are observations without changing what the substance is. It does not change the identity of the substance. So when we go from ice to water to steam, it's all H2O. This is a physical change. Now, the moment I take H2O and I pass electricity through it, I make O2 and H2. That is now a chemical change. So the chemical property, hydrogen or water, will break down into hydrogen and oxygen. That is a chemical property. If it changes, it's chemical, CH and CH. So if there's a change in the substance, that means a new substance is formed. It is chemical, it is not physical. Paper ripping. If I take a piece of paper and I rip it in half, it's still paper. I've just cut it in half. I can still use it for the intent that it had, But the moment I burn that paper, it's no longer paper. It is now carbon, and other stuff has been released, and I can't use it again. Okay, so here are some physical properties. Boiling point, melting point, luster, volatility. Volatility talks about how it evaporates. Hardness, softness, taste, color, slipperiness, odor, ductility, malleability, density, viscosity, dissolving or solubility, and electrical conductivity. Here are examples of chemical properties. Burns, explodes, tarnishes or corrodes, reacts with water, reacts with metals, reacts with acids, decomposes when heated, reacts with nonmetals, is toxic. All of those things describe the changes that we might see so that this substance can react with acids, but it doesn't react necessarily in air. All of those things are different. Okay, chemical properties can only be observed during a chemical reaction. So the formation of a compound, what is that? Yeah, if I'm forming a compound from things, that is a chemical change. The formation of a mixture, so when I mix two things together and something dissolves, it is a physical change, okay? So that's all we have for this one today. I hope you have a good afternoon.